In today's lesson, we're going to learn about the properties of logarithms. And to get us warmed up, we're going to go back and look at some properties of exponents. And as you recall, when you have, for example, 7 squared times 7 to the 6th power, you actually add the powers, giving you 7 to the 8th power. All right? It's the product rule. 9 to the 5th power divided by 9 squared, well, when you divide exponents with the same base, you subtract powers. So we have 9 to the 3rd power. That's the quotient rule. And finally, when we have a power of a power, 5 to the 3rd power to the 4th power, we multiply powers, 5 to the 12th power, and this is called the power rule. So this directly relates to the properties of logarithms, because as you can see, when you take the log of a product, you can actually rewrite it as the log of each of the factors added together, just like we did with the exponents, right? That is called the product property. When we have the log of a quotient, it's the same thing as the log of the top term minus the log of the denominator, right? So again, division of powers, right? Division of the exponents is really subtracting the powers. That's the quotient property. And finally, if you take the log of an exponent, you can actually take the power and bring it down to the front as a coefficient. And that's called the power property. Let's take a look to see how we can apply these to some logarithms. Use log base 4 of 3 is approximately 0.792, and log base 4 of 7 is approximately 1.404 to evaluate the logarithm. A, log base 4 of 3/7. So we know that we can apply the quotient rule to expand this out to give us log base 4 of 3 minus log base 4 of 7. And a quick way that I like to memorize this is the fraction bar looks like a subtraction sign. Just take it and put it between the two of them and write down log base 4 twice. And fortunately, we know what each of these values are without the use of a calculator. So we substitute these values in. And then we simplify, and our answer is negative 0.612. B, log base 4 of 21. So how can we use 3 and 7 to help us rewrite 21? Well, we know that 3 times 7 is 21. So we're going to use log base 4 of 3 times 7. And this falls into the product rule category, because we're going to rewrite this product as the sum of the log of both of the factors. And fortunately, we know what each of these values are. We substitute, and we simplify. Finally, letter C, log base 4 of 49. And 49 can be rewritten as 7 times 7, and that would be the product rule. But we're going to go ahead and write this as 7 to the 2nd power so that we can use the power rule. So log base 4 of 7 squared can be rewritten as 2 times log base 4 of 7. This is the power rule. And we substitute log base 4 of 7, which is 1.404, and 2 times 1.404 gives us our simplified answer of 2.808. And here's some vocabulary for you. Sometimes you will hear the term splitting logarithms to mean expand, and unsplitting logarithms to mean condense. Let's jump in and look at it. I do expand log base 6 of 5x cubed over y. Now there's a lot going on in here. We have division, we have multiplication, we have powers. So we're going to use all 3 properties that we just learned about. First thing we're going to do is we're going to rewrite the quotient as a difference. And then this cannot be expanded anymore, so we're going to go ahead and pick on this expression, this part of the expression, and 5x cubed can be expanded out using the product rule. So 5 times x cubed can be rewritten as log base 6 of 5 plus log base 6 of x cubed. And I would say this is done and this is done. However, this one right here we can rewrite using the power rule. 3 log base 6 of x. And this is our final expanded expression. All right, this one's a little more practice for you to do. As you can see, we use the product rule and then we use the power rule. This time we're going to condense. And when we condense, we want to take several logarithms and rewrite it as one single logarithm. So as you can see, we're going to use the power first, power rule, to rewrite each of these coefficients as the exponent. So it's ln x to the 6th plus ln y to the 4th power. And then we're going to use the product rule to rewrite the sum of both of these logs as a single log, but the product of both of these. So the final answer is ln x to the 6th, y to the 4th. And here's one more for extra practice. Apply the power rule and the quotient rule. And there's today's lesson. Best of luck to you.